Hello friends, welcome to AI Champions Hub, where I try to simplify some of the core concepts as it relates to data, analytics, and AI, and make sure I share my experiences as we apply these to real world business problems. Because I believe there's quite a bit of capability from a technology standpoint, a lot of content available, but very less available in terms of applying it to the real world problems and what it really means to taking this to enterprises, right? So, and I bring my wealth of consulting experience helping clients in this space to help you kickstart. This video is going to be a beginner series, and I'm taking one of these core capabilities, which is regression, and we're going to do a couple of videos. We'll take an end-to-end problem, and then I'll show you step by step as to what it means to help any business problem when we talk about using regression as a technique to help with the predictive capability there, right? So that is the endeavor. So let's deep dive. I have other series, other videos where we look at concept before and after, but this series is specifically going to be focused on regression, and it'll probably be 3 to 4 videos. I'm not decided yet, but it could be a minimum of 3 videos where I'm going to break it. So watch the entire series so that it's easy for you to consume from a bite-sized standpoint, and then you can build on practice and so on. Okay, couple of other things before we get going. Key thing is there are many who are wanting to learn these concepts, but they're not necessarily too good in coding, or they're not interested in coding, even though they may be good at it, right? So I'm going to use a no-code approach to taking you through this journey. I think that's a big differentiator, and today you don't necessarily need to start coding to understand the concept. You can understand the concepts and then maybe even go to coding later. Okay, so that is a no code approach, and we will take a more of an applied approach to this. Okay, all right, let's deep dive into this problem. Okay, so we've been talking about predictive analytics, which is basically to say, hey, can I use my past experience, my history as a company or whatever it is, to say, hey, what can happen in the future? Can I answer business questions which are more forward looking than backward looking? That is the broader concept. And in the context of looking at relationship between attributes, so relationship between advertisements and sales, or demand and supply relationship, or price sensitivity, or any of these elements, there are multiple business elements that impact each other, and we are looking at what is the relationship. And if that is your nature of the problem, then we are looking at what is called as bivariate analysis or multivariate analysis, where we're looking at combination of variables and seeing what is the relationship. Now regression is a problem which will allow us to get the predictive power given one variable in the context of other set of variables, right? Now let's take a look at, I've shown you examples here where we say, what is the impact of promotion on my sales, right? So companies do a lot of marketing campaign, brand campaigns, whether it's TV ads or ads on the social media today. You want to measure whether that's really leading into numbers in terms of sales. So that's one example. Or it could be somebody on the personal health front looking at what's the relationship between weight and cholesterol. So if I decrease my weight, will my cholesterol decrease, and so on and so forth, right? So these are problems where we look at combination of variables, and I'm interested in relationship between particularly maybe one variable in the context of other set of variables. And in reality, I want to be able to look at the sensitivity of the relationship or predictive power of that relationship, and that's what we're talking about. So in the context of regression, what it really means is it's allowing us to get this predictive power, and in simple terms, it's a mathematical equation that will be able to tell you whether sales is increasing by a certain quantum if I increase my budgeting dollars by a particular unit, right? So sales may depend on many variables, but that's just one example, right? So it helps us derive the nature of the relationship. So I have two sets of variables or combination of variables, let's say y and x. And when you plot them here, like you're seeing, this is a simple scatter plot, and the scatter plot is nothing but plotting all your ad and sales data points that you collected over the period, and looking at that to say, hey, what kind of relationships form, right? Now, this is a good starting point usually for you to get a good sense of what that is and where we are, right? I will be sharing this presentation as well as some of the collateral I'm going to use, even including the code. So you can leverage this as you kickstart your journey in terms of looking at it. Okay. So the nature of the relationship, strength of the relationship is what we are interested in. Is it positive? Is it going upwards? For every unit of increase in advertisement, does my sales increase correspondingly? Does it taper at some point? And all of this. So there could be linear relationship. So these data points seem to indicate like a linear relationship, where I say for every unit, there's a corresponding unit increase in the other variable, right? Now there could be a non-linear relationship as well, and there could be business problems where we are modeling those aspects as well. So regression will be a good technique for us to look at. Now let's zoom in particularly on linear regression, linear relationship, because these are easy to understand and comprehend, and that's where we can start, right? So now what are we trying to achieve in terms of regression? So I'm interested in the strength of the relationship, nature of the relationship, things of that nature. Let's assume it's a linear relationship from a nature standpoint to keep it simple. Now I'm interested in finding the strength of the relationship, right? So we saw that scatter plot is a good way of quickly understanding, hey, let me plot all these points in a space and see how it comes, right? So that's the graph we are looking at, y and x. Now, if I were to draw several lines between these, because I'm interested in an equation, and a linear equation from a mathematics standpoint is nothing but, everybody would have heard of terms like y equal to mx plus c. It's a simple relationship that we are looking at. Now that is nothing but an equation of a line. So if I were to draw several lines through this, right, there could be various lines possible, right? So I'm interested in a line which is trying to pass through all of these points and try to cover these points such that the equation of that line, then I can use it to look at the strength of this relationship, right? Now if I draw several lines, many things are possible, but as you can see, some of these lines don't necessarily encompass all of these, right? So if I look at the red line, for example, certain points are far off from the red line, certain points are closer. If I look at the yellow line, some other points are closer, but then few others are far off, right? So my endeavor is to find the best fit line, which is going to encompass and which is going to help me cover these data points that are projected on the map, right, on the graph, if you will, right? So what is this line that's going to encompass all of this if I were to draw many of these lines, right? So what is this? So that is what is called as the best fit line, right, or the line that is going to have the least error when I'm looking at across the data points and so on and so forth, right? So it's an approximation exercise. We're trying to find what is the best fit and the best fit. Now the best fit is looked at in terms of something which is going to give me least amount of error. Now the error is this line is what you are thinking is is going to best define these data points. So there's an actual data point here, and then the line itself is indicating that for a given value of x, this could be your data point as far as the line is concerned, right? Now the element is for us to look at what is the nature of this line, such that the sum total of all the errors is going to be minimum. Now the minimum error, and the error is nothing but a difference between where the point meets and then where the corresponding line is indicating as the predicted value given a particular x value, right? So if I choose x here, what the line is saying, hey, your y value somewhere here, but in reality the y value may be a little bit on the high side, right? So there could be error factor, and that error is the difference between what you're predicting and what actually is there. And we are trying to find out what is the line that's going to give me the minimum error. And mathematically, if you look at it, the minimum error is if I draw a perpendicular from this point to the line, that is perpendicular is going to give me the least amount of error because that is the closest point. So the point is closest to the line at the point where if I draw a perpendicular and whatever is the value I get, that's the least, right? So that's why it's a least element. And then we are looking at least square so that positive and negative elements are taken care and we are covering for the error, right? So by and large, conceptually, you will look at it. If I take a square of all these errors and I total all the errors, I will get some value, and I am looking for a line which is going to give me least amount of this error, right? And that line is what will be your regression line potentially. Now, that is, if that's my regression line, what it means is that that line can help me predict the relationship and the strength of the relationship or details, from that perspective. Okay. So what is this equation that we will get once we get the line that's going to be the best fit for all with the minimum error? So you will get some simple equation. Don't get very bogged down by the complexity of the equation or anything like that. It's quite simple. Just focus on the concept. So the line is it's got a couple of components, as we know from a line. So there is a slope of the line. Slope of the line is indicating the angle at which it is moving up or down, right? So if I go through the slope up or down, it's basically saying what is the increment for a unit increment of x, what could be the unit increment of y, right? So that's an indication of this. It's a factor that helps us understand what is the nature of it, and it's in simple terms, think of it as an angle of the line, right? And that's one part of it. Second is intercept, which is beta naught. So intercept is there will be a minimum value that you will get. So let's take, for example, the sales and the advertisement as an example. Now, even if I didn't advertise today, you have some brand value in the market, you have some name, and therefore you will have some base level of sales going for you, right? Even if I didn't do anything, somebody is going to buy, the product, right? And that base minimum could be, for example, use your beta naught, right? Absolutely zero. If I didn't spend any dollars, what could be the return, right, in terms of sales? That could be your intercept. Now, if I spend a unit of value, the unit could be in 100K, 200K, half a million, whatnot, whatever is the unit you choose. And then I can see what is the unit increase in terms of sales correspondingly. Is it million, 2 million, 3 million, and whatnot, right? So that is the thing. So this equation is going to help us with that. There'll always be some bias term because it's difficult to get the perfect line. There will be some residual errors for which we will not be able to get. So our idea is to get the approximate, the best possible line, so that then we can decide whether I can use it for my business need or not, right? Okay, so this is the concept in terms of what a regression is. I'm trying to find a mathematical equation that's going to help me with my business problem that I'm looking at, right? One last thing before we get into the actual end-to-end problem is two terms that you need to be aware of. The x's which I'm trying to give as in my input, they are called independent variables, and what the value I'm trying to predict is my dependent variable. So in the example that we talk about is advertisement dollars, or whatever is the spend and the input you're going to put in is your independent variable. And then your dependent variable is, let's say I'm trying to understand sales, how much sales is going to go up or down, may not go down, but pretty much go up. So the thing is, it's dependent variable, as you can see, right? So in this case, sales would be my dependent variable. And then I'm trying to see, hey, advertisement across various channels. If I spend $1 million here on TV, another million on social media, XYZ, all that, what is the net impact in terms of this, or what is the relationship? And those are my independent variable. Okay. All right. So that is from a quick concept standpoint. Now, when we talk about these regression elements, we follow a set of steps. I talk about a 7-step approach, and we will take a real world example and walk through the 7-step approach. And in this part of the video, I'm going to introduce the first 2 steps with an example. In the second other videos, we will look at a couple of other steps. So what are these steps, right? At a high level, I'm going to give you a quick rundown of this, and then we can, as we deep dive, we will get into the details, right? So I always start with, in any of these analytics engagements, start with the business problem. What are we trying to achieve? What is the objective, right? So that is what we are going to start with, and there's a lot of detail, and as we look at these details, we will be able to see these parts. So we will deep dive in each one. Don't worry about it. Let's just get the feel for it. So I start with what the business is, what are the challenges, what is the problem, what am I trying to achieve, right? And then try and see if we can frame it into a context like we were talking about around impact of sales, given a certain input in terms of advertisement dollars or such examples. Okay. Then I'm going to say, hey, okay, now I know what I'm going to solve for. What am I going after? Let's talk about where can I go and collect the data, right? Sometimes it's easy to say, hey, this is my spend on ad and XYZ, but it may not be very easy to collect that data point, because you would have had many channels, you could have had many systems that are probably capturing this data point. So data acquisition is a key step, which could take time or it could be easy in that sense. So in our problem, we assume that the data is available, but we'll talk about elements in terms of how I may typically go about looking at data acquisition. Okay. So once I have the data, the input data I want, most likely it may not be ready for you to directly start consuming it in terms of building a predictive equation. So we start with what is called as data analysis and understanding to say, hey, okay, I've collected this data, or this is made available to me as an input. Is it good enough? What's the data telling me? So I want to go and start looking at getting a deeper understanding. That's my step third. So once I understand my data, then typically we start to prepare this data so that I can look at model. You may have several attributes that are available. Some of them could be noise, some of them are needed, some of them are not needed. Given your business problem, you may want to say, hey, look, these attributes seem to be important for my problem, or there is data quality issues with certain set of attributes. So considering all of that, you may want to quickly look at what can I prepare such that I can build my input for the model, right? So preparation of data is a key step. So as you can see, there's quite a bit of work that happens leading up to building the model. Then step 5 is, now I have my data ready. I know what I primarily believe, given the objective, what are the elements that could be helping me. Then I go and build the model, right? Now I can start to say, hey, looks like, obviously we would have said this is a regression type of problem, and we are going to build such and such a model, right? So now I use various techniques, build the model. Once I have built the model, I can go and start looking at fine-tuning the model, because we don't typically just build one model. There could be multiple techniques, combination of techniques we use, and out of those combination of techniques, we try to select. Now, other thing you have to remember is, this is an iterative process, right? I could go back as I'm building the model. Maybe I'm not happy. I can go back to better analysis of the data, deep dive on certain attributes, maybe even go back and acquire additional data set, or even go and prepare the data set, whether it's new features or other things. So this is not just sequential waterfall type of approach. Think of it as an iterative approach. Think of it as an approach where you may be iterating through these steps depending on the situation where we are in, right? For now, let's understand the key steps, but keep that in the back of your mind as we go through this. So then we talk about fine-tuning the model, having run through various techniques, and I've gone through multiple iterations and I'm happy with it, and finally I've selected a model that I want to go with. Now I've selected a model. I think this is the best fit regression approach that can help me. It could be even simple linear regression, and I get an equation and I'm happy with it after all the fine-tuning and everything that after all the attribute selections and everything that I did. So finally I go and look at the model and start to say, hey, look, what can I do? how can I make it better? Is there an opportunity to do other ensembling techniques or other techniques to make it better, or even go and fine tune certain parameters and look at it as a generic step? Okay. Once I have decided this is my final model, after all the selection and everything, then I can go and make it a production ready application, right? So a model by itself doesn't help anybody. We have to make it from a business standpoint. I'm saying for a business user, they need to get an application, they need to get a service, something that they can go and use along with the business application they're looking at. So I may have to make it part of my marketing application to say, hey, given an advertisement dollar, does the sales increase or not? It could be part of your campaign management system or something like that, which you're building, and you have to make this model part of that pipeline of work, right? And that's the model use. This is a very important step because that's where a lot of things may fall apart if you don't do the right thing and the users don't get the right element. The other part is the models are not one-time built. They need to be living and growing elements. So you need some way to make sure as you're getting new data sets, as you're getting new inputs, you're able to adjust the model and continue this pipeline, but not disturb the business use of these things. Okay. So there you have it. You have the 7-step approach where we quickly look at the data elements, preparing it, go through the model, iterate through these steps, and finally make sure there's a predictive element that I can use for business. Okay. So this will give you the steps. Now let's talk about what is the problem that we are going to take and run through this in terms of the end-to-end part. So I'm going to use a popular data set called housing values from the region of California. So this is a popular Kaggle data set that was being made available. So if you look at, you could Google and find out for yourself as to what that data is. So if I go and look for California housing data set, okay, you will find this in Kaggle. I've already downloaded it. I'm just showing you as to where I can find. You may have to sign in and log in, but this is the data set we are going to use, right? Now this data set is used in multiple books as well as part of Kaggle, and there's wealth of information available. I'm going to try and focus on making it easy for somebody like a beginner to get going in terms of this, right? So what do we have in terms of the data set itself, right? So the data set is nothing but they've collected a lot of data from California districts in terms of housing prices, right? Now, what is the idea and the objective that I may go through? There could be a variety of things that depending on the type of use, but by and large, if you look at it, let's say I'm a mortgage company or I'm a bank, I'm interested in looking at loan or whatnot, right? So I'm trying to see, let's say you're a mortgage firm or a real estate agency, and you're trying to say, hey, what could be the price of a house given a set of input parameters in a particular district, right? So the input parameters are given the number of rooms, bedrooms, number of household in the district, or some medium income values. Given certain inputs, am I able to predict the house price of a house in a particular district, right? Is it high in Northern California? Is it high in the Southern California region, or anywhere it is, right? So this is the objective is for us to see, can I predict the median price of a house given a set of inputs and so on and so forth. Okay. So this is the data set. I have the data set with me. We have prepared that part. That is one part, right? So before I go into the tool and the no code approach, I'm just going to zoom in on the front end of this whole aspect so that we talked about. Okay. So my business objective is, let's zoom in further. I'm going to remove these two elements. They're a distraction for us in terms of the logo is not needed now. Okay. So let's zoom in further on framing the business problem. So now that we looked at, so I'm interested in predicting the median price of a house given a set of districts and the data points given from the district standpoint. So that's my problem. right? So so typically you may want to look at a couple of other things. What is the use? What are the benefits? Other things around assumptions and hypotheses that I can draw, right? So let's stick to the core. Let's say, for example, I want to find out what is the use. Why am I doing this? There could be a variety of reasons, like we said. Maybe the current situation is people are collecting a lot of these data points manually. They are doing surveys. They're talking to various other third parties or whatnot, and they're collecting the census data and so on. And they are doing manually. And in the case of manual situations, the error rate could be very high, or it may take longer, and so on. So whatever your situation is, try and find out what is the current situation, what is the current state, what is the use, and how am I going to benefit by building the model? Is the model going to deliver any benefit? Is it going to be incrementally valuable as we go through this, right? So the benefit could be in terms of, obviously in this case, let's say I'm moving them from manual to a mathematical approach and a data driven approach. And in that case, there's a good opportunity for us to improve the accuracy of this, right? So in manual, like we said, there could be, it's people dependent, it could be errors, somebody can make mistakes, and so on. But if I have a systematic approach of going through this, then I can get a better accuracy, right? Lower the errors, better the accuracy. Speed could be another factor, right? Once I build this model, I could make it part of a pipeline. As soon as I have data, I could get a model output and I can decide whether it's giving me something of value that I can go with, right? So there could be various benefits. This table all your use, benefits, put it in the context of business from a functional standpoint, and then try and frame your problem. Now, the second part is what I talk about as the expectation, right? So when you're dealing with clients, when you're talking to end users and business, assume that you're building this model as a data scientist for a company, or it could be a bank, it could be a mortgage player, any of these. You want to understand what are the other expectations around this, right? Now the overall expectation, we said, okay, I'm interested in predicting median price of houses given this set of inputs, and we established that the input data itself has several things, and it could be a regression problem, and we'll zoom in on that part in a minute. But we established that overall I want to predict value, and this could be a single value given a set of input. What could be the best case price, right? Second is what could be the performance factors, right? How soon do you want it? What are the expectations in terms of acceptable rate of error, right? So you want to understand, is it good enough if my model is 70% good, or do I need it to be 99% good? So there could be healthcare and other situations where you may want the accuracy and other parameters to be of a higher value, right? As high as possible, so that you can decide on whether to put it in use or not. Then we talk about cost and time, right? I mean, I can keep collecting my data, I can keep running these models and so on, but sometimes we don't have that luxury of unlimited, infinite time. We may have to probably get this out of the door in a 2-month period or a 3-month period. Maybe there's a transformation that's launched, digital transformation of some kind, and you are working towards a deadline, right? And there's a limited budget, right? So all of these are constraints. So we want to put the constraints, put these assumptions, and say, hey, what is my expectation? And also from an use standpoint, right? What is the expectation in terms of making it? Is it going to be part of a web application? Is it going to be part of my CRM app? Whatever it is, right? So this expectations are important to look at. And finally, from a business standpoint, so having looked at the benefit, the problem statement, the benefit, the use, all of the expectations from a user standpoint, one other aspect is you want to get a look at the baseline, right? Now the baseline is typically what are they currently working with. So what is the current state of the situation? Is it obviously we were talking about earlier around, it could be a manual process. Somebody's collecting all of this data in an Excel sheet, and they're probably doing some pivots and things like that, and doing some basic Excel manipulations and so on. Not to say that that's good or bad. It's just that is the current state. But as we established, there could be a lot of errors, accuracy issues, and we are always trying to see, can I do better, right? So what is the current situation? What can I do, and what are the other alternatives? Maybe your alternative is to just get an SME and see if there's an access to an SME or access to a service, it could be better to go with that, and rather than building your model and collecting the data and so on, and see if that helps anywhere, or even that gives you a baseline, right? Sometimes that may not be a solution approach, but that could be establishing your baseline in terms of saying, hey, the service is giving me a certain degree of accuracy, they're able to predict, can I do better, right, by building a regression model and so on. Okay, so there you have it in terms of step one. So I quickly go through in the context of business, try and understand all of the contours of the input from that perspective, right? So we talked about what is the objective, what is the end state, how the business is going to use, what are the alternatives, and all of that good stuff that we talked about. Okay, all right, let's move to the second step. Now, in a real world situation, now that I know what I want to go after, I'm trying to predict the business value. In this case, we've been given the data set. Somebody has gone through the pain of collecting this data set and making it available. But in reality, that may not be the case. In a business sense, you may have to go and collect the data, talk to different folks, and so on and so forth, right? So therefore, in that process, we will just go through the process, because here we are trying to understand the process from a broader standpoint. Certain things we cannot simulate here, but in reality, in your consulting engagement or in your projects, keep these things in mind, and this will be of value, right? So first thing is, we were talking about framing the problem. We know it's a prediction problem. So I want to clearly understand in terms of data, what is the target variable that I can go after, right? Now, so first thing is, what type of data I need, zoom in on the target variable and zoom in on other attributes that you can go and look at. Now, the target variable in this case, we said, is the Y, which is the median price of the house at a district level. We have the lowest level of information we have here is district level information around district population, household, and so on. As we saw from the data set here, it's at a district level given California district 6YZ, right? Now, I'm trying to understand what is the median housing price at the district level. That is obviously the key variable that I'm interested in. Then after that, I want to see as many other attributes I can collect, whether it's number of households or number of rooms, location, any of these factors we know from a business standpoint that are going to be helping with the value of these prices. So we know certain common sense things like, if location is a big factor in many cases. If it's in downtown LA, the price could be different. If it's somewhere in the desert, the price could be different, right? Not that anything one is better than the other. It's just that nature of the demand and supply and other economic factors that may play into it, right? And then income level also will be impacting the entire median house pricing, right? So you collect all of the data, that as much as you can, and then see what we can get a handle on, and so on. Then from an ongoing standpoint, you may want to see on an ongoing basis what could be the source of these data, right? Is it an application that's going to provide me this data set? Am I going to have to subscribe to some external data feeds or market research or whatever it is, right? So you may want to see what could be the source, particularly from an ongoing standpoint. It could be a database, enterprise application, external service. All of these become important, right? Then the question of, okay, I know these sources, how are they going to provide me this data, right? There's a larger data engineering element that goes through it. So if you have a data engineer, they will be able to help you with saying, hey, what is the foundation? How am I going to work through making the data available to the model on an ongoing basis in a systematic manner, right? But the simplest element there is to at least get a landing zone. What we call as a landing zone is a zone where it is an interface between the systems that are providing the data and the analytical systems that we are building, right? So it's an area where somebody is going to drop a file, or I may go and pull from a database, or my external agency may drop data here, whatever it is. So it could be landing zone. Obviously, it has to be secured and all of these good things to be factored. But just remember that storage of how this is. So once you decided on the source, how am I going to store on all of these becomes factor that are important for you. Okay. So in this case, as you can see, this data is, when I download it and so on, it is available to me as a CSV file. Okay. Now I am going to, and then just a quick point, you will see that originally this data set appeared in Kelly and Barry's paper and so on and so forth. So you can see how the original data set came in. You can go and read through that if you are interested further. Okay. All right. So now that I know, so in this case, we have been given the CSV file, and that's our starting point. But in reality, you may have to go through these other steps as well, and that could be part of your pipeline of project work or methodology that you may talk about. But you can use these steps as a starting point. Okay. One last thing before we stop here and then go to the next part of the series. So we'll conclude the series with these two first steps. Is I want to introduce you to the no-code approach. So what is the no-code approach that we are talking about? So I'm using a tool called NIME, and NIME analytics platform is an excellent platform for you to get going from a analytics standpoint. It's got a big community, many people are using it, and so on and so forth. So you can Google and go type NIME, KNIME, and you can log in, register, and you will be able to download the analytics platform and so on and so forth. Okay. It's a big community. A lot of I have found this to be a very valuable tool. There are other no-code platforms. You could use SageMaker or H2O and other things, Data Robo, or there are many products, right? So these days, no code. So your alternative is to go and write Python code using either Jupyter Notebook or your own custom Python install on your local and then build the model. The tools also allow you to do the same thing, right? They help you all the way go to the model, build the model, and so on and so forth and so on. Okay. So here we are using a no-code approach, and I'm using this platform called NIME. I'll do a quick introduction. This is not I have separate video where I've talked about what is NIME and how can I get started. And there are also a lot of videos available as part of this community. There are a lot of excellent people who put quite a number of videos and solutions to get you started, and you can get going. Okay. There's a lot of information here on their site. Just explore these resources, and there are a lot of blogs, documentation, and so on and so forth. Okay. All right. So now when you launch NIME, you will be able to see that as you launch, you will get I'll just introduce to the basic. So if I go to home, this is a new UI. There's an older UI available. You can switch to the older UI as well and switch to the classic model. But essentially, the newer UI is this. You will be able to see what is your local space and so on. To keep it simple, all I'm going to say is install NIME. There are two key things you may want to look at. So you will be installing NIME, and I have installed it in my local E. So wherever is your version, you just install it, and then one thing you have to indicate is the workspace, right? So I have a lot of other models, workflows, what we call as workflows. Now these workflows are to be saved in a folder, and that is the thing that you need to indicate with what is the workspace, where am I going to store it. Those are the two things that's needed, and then you can get started, right? So my local space is a folder on your computer that stores access. That's what they're talking about. It's essentially somewhere where you start putting your projects and project repository or whatever you want to go with. Okay. So now I have my local workspace. It's in E drive. And once I've indicated, I can quickly go through this. I don't have to point to that every time. So the moment I say, so if you look at it, these are my working workflows, finalized workflows, XYZ, whatever I'm doing, right? If you look at it, this is the subfolder. So I've just called it as AI Champions Hub, workspace, and I keep putting things here. And as I'm working through and I'm finalize certain things, I'm going to put this in the final folder, right? And there could be many workflows below this, chatbot, XYZ that I'm building as I learn through, as I'm making it. And then there are things I move to the finals. There are some things I keep it temporary, whatnot. So these could be subfolders. It could be marketing project, could be technology project, whatever your organization or setup is, you may want to organize that, right? Second thing is I can import workflows. If somebody is making a workflow available, you can use it as a starting point. You can create more folders, things like that, right? It's as simple as that. I can just create a temp folder, XYZ, and get going. Okay. So once I open a workflow, I will get to something like this. It's a NIME is a development environment, and the entire community allows you to host the models and so on and so forth as well. And I build some kind of a workflow of this nature, right? So there are a lot of good things here, and typically you will see that these are called widgets, right? Just to keep it simple. So I may have widget for treating missing data, reading a CSV file, building a predictor, right? Understanding visuals like statistics about the data or so on, scatter plot and so on and so forth. So there are various widgets available. You build these workflows in terms of sequence of steps. So when I start, like a blank slate will be like an empty pane, right? And then you will see that so the blank slate will be as blank as this, right? Now I can go and add annotation to say, hey, this is sample comments XYZ in terms of so I can add my comments and all that. I can make it whatever header 1 or 2 and or so on. So you could say, hey, this is my regression problem, these are my steps, and then go to the left. You will be able to search the nodes. So in this case I'm going to say, hey, how do I read a CSV file? I can just type CSV and all the widgets related to that will come. I want to look at regression as a problem. There are various nodes available for you to do regression related. Some may be related, some may not, but by and large you will see that there are widgets that are available. So there's a linear regression which we will use, and so on and so forth, right? So now I have this. How do I use it? So all you have to do is just drag and drop, and then you will get a couple of things for you to get started with. I will just introduce you to the key things, and then we can look at the other video, right? So let's say now I have CSV file. I'm going to double click on this what do I call it, as a dial button or a one of these things, so which says config, or you can hit F6 like it's pointing. So I can just double click and it will open this window where I can go and configure, right? So in this case, for example, we are reading a CSV file. There are various options. I could read it from a local file system. I could read it from a remote mount point. I can read it relative to the workflow. So I may have a data folder. So typically what we look at is we create these. So let's say, for example, I'm working on, say, let's just go to this California problem that you're looking at. So I've created this workflow, and then under that data folder, I've downloaded this housing.csv file, and I've kept there. Right now, let's have a quick look at it. So as you saw in the Kaggle portal or other portals, you'll see that this data set has set of attributes that are available, right? Now, what are the attributes available for us? You will see this longitude, latitude, housing, median age of the house, total number of rooms, total bedrooms, population, household, number of households, median income of people in the district, the value. So this is the median housing value, and this is what we are interested in as the variable that I'm interested in. This is the dependent variable, right? And proximity to ocean or not, and these are the things, right? So as you can see, it's a CSV file. I can open it, I can look at it. That's a no-brainer. Now you can see that this is my input. This is available to me as a base data set. When you download from Kaggle, this is what you get. Okay. So now this file is what I'm interested in reading as my first step. So I could say, hey, look, relative to this, just open this. So if I just say relative to this, and if you had put it in a data folder, you will be able to open this. Give me 1 second. No, I think I am in a different, so I'm in this, okay, so let me just put the same CSV here. This is a different workflow, it's in a different place. So I'm going to just use this, so we'll just use this as a first thing. So I've already built this CSV, so I said relative to the workflow, relative to my current workflow, where is my file? I've indicated that, and it's quickly able to read this. Now for you, I will just show you what this file is. For example, if I go and save as, right, where does it go? And so it's in the local folder. I can save whatever it is, but I'm just saying this is the workflow that I'm working with: regression, housing prices, beginner, step A, EDA, right? So if this is my workflow name, where I have stored it is same thing. It's housing, beginners, step A, EDA, whatever it is, the workflow name you would have given, right? And then my data folder, my file is here. Okay, so this is where I'm reading from, and I've kept a data. The data file is under the workflow. Typically, my recommendation is create a data folder and then put your data files there. Okay, so now that we have that, let's go back to our NIME workflow. So this is my first step where we are talking about CSV reader. We have configured it. Now when I say .housing or whatever XYZ file name you have, if you put it under relative to the current workflow data area, NIME will automatically read it. Or you can always browse and go and look at this file, right? So that's not a, you can always pick and say, hey, go to this folder, look at it, and so on, right? But since you're wanting to make it, part of a production pipeline, even for ongoing, you choose an area where we talked about landing zone or common interface folder areas where the file may be dropped, right? So this is have an area where this file may come in. That's your interface with the source systems or data engineers, wherever they're going to put it, and that's your starting point. Okay. Now there are a couple of other things. I can quickly specify the format. This is a comma separated file. So I'm saying, hey, the columns are separated by comma. It could be tab, it could be other things that we are delimited by, right? Then you're saying whether the data file has a column header or not, you're indicating it. If I say there's no column header, it'll read the rows as is. The moment I said it's got column header, it'll show me that longitude, latitude, and all of these other columns. You can see that they come in as a names, right? Then I can also indicate similarly whether there's a row. Now there are and when you're building enterprise applications, you will see that row identifiers are important. So let's say I'm looking at customer data, I could have customer ID as my row ID, right? So whatever is an identifier, in this case it could, let's say for example I had district ID as an example, right? In this case that's not available. Let's hypothetically assume there's a district ID available. Now my district ID could be my row identifier. It's essentially saying I have all these attributes. What can uniquely identify this row or so, right? So if I had any attribute that was uniquely going to identify that, usually your primary key from the database or any of that, you could indicate that. And if you say yes, it will not generate. If I don't have one, NIME will be able to generate one, and you can see that they are sequential numbers that are generated. Okay. Alright, so that's all the configuration you need to worry about. Then if you look at the next tab, you will be able to see in the transform, I can specify the data type that I'm interested in. Let's say I want to read all of these as string. It's automatically able to interpret that this is a number and it's a double and so on. But if you want to indicate that it's a string or any other data type, you could do that. In this case, that's not needed because all my values are coming as is. Now, most of these are numbers. One thing that we talked about is the proximity to ocean. Now, when we looked at our data file, we saw the proximity to ocean is nothing but a set of values, and we will see that set of values in a minute. Now, if I go to Excel, I can do a quick filtering, and then I will see that there are about 5 combinations. So, is it near the ocean, near the bay, is it inland, and all of these combinations. So, this is called categorical variable. Now, these categorical variables they are string coming in from the input file. They are string. All others are numbers, right? So that's why ocean is interpreted as a string, and you will be able to use it as a categorical variable. Okay. All right. Now this is what a quick preview of this. So those are the main things you need to look at, and then you can talk about how much you're going to put it in memory. These are some of the production ones, and I will not worry about it now. But by and large, you will see that we are able to read the data file and we can get going, right? Now, a couple of other things I want to talk about quickly around NIME so that you can get going, which are common things. So a widget, typically there's a config piece like I said, and there is an execution piece. Let me just reset this for a minute. So if you reset the node, that means the node is not processed. But then I can click on execute, which is F7, or this button that's available for you to click on. The moment I click on that, it will execute that widget, and then the lights will turn to green. It's like a traffic light. So you can look at it, and it will be a green light. Right now, once that's there, I can see the output. What it means is I can see the output of that widget, and then see what is happening there. So in a CSV reader, the output is all this data values that it's able to show, and I can also look at if you click this filter, you can quickly say, hey, if I want to just look at, we were talking about bunch of things, right? So what are the values, set of records around near zone and inland ones and so on. So what about houses near ocean? What are they looking? How are they looking like, and so on? I can just do a quick preliminary analysis here and browse through this. I don't have to go to Excel sheet and filter and open it. I can do certain basic key things here itself, right? Now, if you don't select anything, the filter will show all the values and so on and so forth. Okay, so we will get into the detailed analysis as part of the step 2, like we said. But for you to get going from a widget, from a NIME standpoint, all it is, be aware that there's a area where I can go and search for widget. I can look for anything, drag and drop, start connecting. It's as simple as that. It's very easy for you to get going. Configure the node, and then we will go from there, right? Now, one thing before I conclude this part of the video is, there are a lot of steps available as we process, right? But my endeavor typically is to keep the documentation simple, keep the flow simple, so that business or anybody doesn't need to worry about all the things that are going behind the scene, and you yourself can organize your work into proper steps and so on and so forth. So NIME provides this construct of, you can create, there are two things available. I'll just touch on that so that you can. So if I click here, so there are two things available, or you can see it at the top: create meta node and component, right? Components are more like reusable things which you are going to use across models. Let's say I do like pre-read a lot of the same customer data, and I can create a component for reading customer data, cleaning everything, typically, right? And I can use it across my market basket analysis or cross-sell upsell model, or any of these, right? So let's say I could create a component, or it could be a technical component, and I can use that component. It can come in like this, right? But the other thing, what I typically also use is create a meta node. Now a meta node is nothing but it's grouping set of widgets and coming and helping you there. So I showed you like a regular workflow where you can either keep all these workflow elements sequentially going, but sometimes it becomes too much and too complicated. It's not readable, it's not easily. So in this case we don't have many, but let's say I had 5 more widgets, it will easily become little difficult, particularly when I add comments and so on, right? So therefore what you want to do is group them, and then this is the meta node. So I have created a meta node for each of these steps, and then we will go through these things in the next video. But you will see that I can group set of widgets, I can organize my work very well, and it's very clean and simple. So I can say, hey, if I want to go zoom in on the data analysis part at some point, I can go there. But most likely, let's say I'm in step 4, I'm not bothered about what's here, then I don't have to worry about it. I just group them, and it's more readable and so on, right? And I can put these commentaries. So let's say whatever is your commentary, you can put that, right? And so for example, in this case, I see that there are 20,640 nodes. I can just copy that, put the comments and so on and so forth, and then we talk about 10 columns there. They're all of data type integer, and we will see all of this in the next video. But I'm just saying, you could just put all your commentary there from a NIME widget standpoint, and this can be very clean and so on and so forth. Okay, all right, so there you have it. It's we went through, what did we cover in this video? Let's just go through the quick steps here. Now you will see that we went through the first 2 steps: framing the business problem, what is the use, what is the expectation, and all of this. We are in solving a housing prices problem. Then we are looking at acquisition of the data. In this case, we got it from a CSV file, and I'm using a CSV reader. but by and large you may want to go and acquire this data source and go through this process. We looked at some of these things, right? And we are using a no-code platform called Nine. Introduce the Nine part. Now we will get into the core of it in the next video, where we will get started. I would say go download Nine, get set up, go download the file, and you can start working along with me in the as we're going through this video, so that in the next video you can start to play with it like I do. So in the next video we will go through deeper understanding of the data analysis. We'll zoom in on everything, and then we will start to look at thereafter preparation of the data and the model and so on. Okay, hope you enjoyed the video. Do send your comments. If I can make it any better in any of the elements are not easily understood, let me know and I can help you with this. All of this content that I'm showing you, whether it's the mind map or the Nine workflow and so on, I will share them in the link in the description. You can download it and you can consume the same. Okay, thank you very much. We'll see you in the next video. Hope you enjoy this video. Do share your comments and feedback, and let's talk in the next video. Thank you very much. Bye bye.